going to talk about glute transporter. We have glute 1, 2, 3, 4, and 5. Glute 1 is the transporter that is mainly in all the cells, especially in the brain, placenta, and erythrocytes. Now, the glute 2, this is a bidirectional glucose transporter. That is, we have the cell, here is the glute transporter, and the glucose can go in and out in the glute 2, think as bidirectional glute 2. And this is only seen in liver and pancreas. Next we have glute 3. This is seen in placenta and brain. Glute 4 is expressed by insulin and is only seen in skeletal muscle and adipose tissue. But in exercising muscle, the glute 4 can be expressed only by exercising muscle. So for that is good to do exercise. Glute 5 is not a transporter for glucose, it's a transporter for fructose. Now a little bit of the absorption. We also have the sodium glucose cotransporter. We have a intestinal, and this will be seen in intestinal cells and kidneys. Let's say this is an intestinal cell. We have the sodium glucose cotransporter, so taking advantage of the sodium gradient, then glucose goes in. Glucose goes in for this sodium glucose transporter and goes out by the glute 2. And we're in the intestine. Oh, sorry, here intestines also have glute 2. Now, so here can pass from this sodium glucose transporter can pass glucose and galactose. So passing here, and this is the intestinal or the apical phase of this intestinal cell, and this is the basolateral side. So now glucose goes into the blood through the glute 2. As you see here, glute 2 is permitting glucose going out of the cell. And for fructose enters the cell through glute 5, and can go out of the cell through glute 5 or glute 2, and it is mainly by glute 2. Now, some differences of some enzymes that we already studied in biochemistry, but let me remind you: difference between hexokinase and glucokinase. Remember, we have glucokinase is only seen in pancreas and liver, and hexokinase in every cell. They both take glucose and phosphorylate to glucose 6-phosphate. The inhibitory product will be, that is the one that produces feedback inhibition for glucokinase, will be fructose 6-phosphate, and for hexokinase will be glucose 6-phosphate. Now the affinity, remember that affinity is inversely related to Km. The Km for glucokinase is, we know that glucokinase has low affinity for glucose, and so the Km is increased. In hexokinase, the affinity is increased for glucose, and so this leads to a decrease in Km. And in Vmax, the maximum velocity of the reaction is very high for glucokinase. It has high Vmax, and for hexokinase a low Vmax. Insulin promotes the activation of glucokinase and not of hexokinase. In the next video, we're going to talk a little bit about the fructose metabolism and galactose and glucose, just in some tissues that this is This is intended to set the background to diabetes cataract.